Hello everyone and welcome to this talk about the blockchain. So how many of you don't give a shit about the blockchain, are just here because they saw some light? Okay, that's reassuring. By the way, our goal is by the end of this talk that nobody raises their hands on this question.
We hope.
So yeah, the title of this talk is why the hell should you, why you should care about the blockchain.
Yeah.
So very quickly, before we get our hands dirty with the real material, a quick presentation about who we are. So my name is Sebastien Arbogast. I am a developer for over 11 years now. Mostly Java backend stuff and also a convinced agile practitioner. I also coach startups on everything related to lean startup methodologies. I'm an entrepreneur. I created my own business a couple of years ago, and also do some development on smartphones and smart TV. So, by the way, if you have an Apple TV, you can use TVox application to watch all the talks from Devox. Shameless plug. And I also blog on futurologist.co because I like to view the future, like Irma stuff, crystal ball, and all that. And indeed, of course, the reason why I'm here, I'm also blockchain enthusiast.
So I'm Said Eloudrhiri, and I started my career in 1992. I was young and thin.
And developing on punch cards.
Yeah, exactly. So I'm an agile coach. I love Scrum, and I'm also leading some guys. So, and I learned programming to kids with the Devox for Kids initiative. I'm a co-organizer of the WAJEG, an organization located in Liège. I'm an entrepreneur, and from time to time I'm developing some application, mainly on Android. I have developed the Android Wear app for my Devox, and also TVox, the counterpart for Android TV. And I'm a fatherologist. I have predicted to have 3 kids, and I have succeeded for that. And also sometimes I try to develop for the blockchain.
So just a few disclaimers before we start. You might have heard of the blockchain via Bitcoin and all the cryptocurrencies and so on. And most people use it today as a speculation instrument. We are not interested that much in that part.
No.
Clearly, we are developers, so we are looking at it from the angle of a developer as a development platform. So we're not traders, we're developers. And also, we are not experts. We don't pretend to be experts. We are just learning about it. And our goal today is to share what we've learned. If there are experts in the room and you notice some inaccuracies and so on, feel free to tell us and we will improve our content.
Can you draw a kitten?
With blue ink.
Okay, so Sebastien, we have read a lot of articles and posts regarding the blockchain here and there. So it's really hype. Could you just explain us what is the blockchain?
That's the most fundamental question, and thank you for asking it because
you're
that's
welcome.
The next slide, amazing, as if it was prepared. Anyway, so most of you might have heard of the blockchain via Bitcoin. Okay, we all know that the blockchain is the technology behind Bitcoin. Bitcoin was born somewhere in 2008, right after the subprime problem issue. And a guy by the name, or group, we don't know yet, by the name of Satoshi Nakamoto, came up with this white paper and a code base for a basic system whose goal was to basically replace the banking and the currency, the fiat currency system, with a completely different kind of currency, a digital currency, a cryptocurrency, that could be maintained without the help of nation states and banks in a completely decentralized way. And it kind of shook up a whole lot of things. And indeed, it was, the blockchain was not even a concept back then. In the white paper, he just talks about a chain of blocks. And later on, it's only later on that we realized that this concept, this architecture really, was really interesting for a whole lot of other problems than just creating a currency.
Okay, hold on. Cryptocurrency architecture, I'm lost. Could you explain the difference?
You're right. That's clearly a problem right now, is that on the Bitcoin everything is mixed up because, it was designed to solve a very specific problem. But it's very important to differentiate those 3 different layers. So you have a conceptual layer, a set of design patterns if you want, a set of generic concepts. that can be applied in different ways, and then you have implementations. Each implementation can choose their own concepts and implement them in a specific way. And then even for each implementation, you have different instances. So it's really important to differentiate the three. So let's start with the concept first.
Okay.
So let's go back to the problem that the Bitcoin was supposed to address.
Smile.
And very natural, as you can see. So if you put yourself in a very simple model for a banking database, if you want, you have this database that stores a balance for each bank account, and then you have transactions that are applied to it. So in the first scenario, we could say that after this state, we do a first transaction, we transfer 5 euros, dollars, whatever, it's the same, from Alice to Bob, and then 10 from Bob to John, and then 5 from John to Alice. And we end up with this state, 15,015. Now we just change the order of transactions and we put the second one first. Okay, we start from the same state. This one won't work because Bob doesn't have enough euros on his account. And so then we apply the other 2 transactions and we end up with a completely different state. All that just to illustrate the fact that, of course, transaction order is really related to the state. And that's the main thing. You need to agree on an order of transactions in order to agree on what the final state looks like.
Okay.
Okay, so that's the first key element. When you have just one database, everything is centralized, it's very easy to find this agreement. And even if you have several databases that are somewhat replicated, it's pretty easy to find. Okay? But then it comes with a whole lot of problems. The first one is, okay, what happens if someone who has access to this database finds a way to change the order of transactions, or even to change the state directly? Of course, it's a very big problem, and that's why most banks work with those mainframes that nobody likes, but it's very secure, it's very safe. So basically, how do you deal with mutability? The second problem, what if the database fails? What if the central system falls apart? Then nobody can access their accounts, the whole system is down. So how do you deal with fault tolerance? And the third problem with that kind of centralized system is who can see what, or the problem of censorship, basically. So in a centralized system, the way we deal with those problems, well, mutability, basically we set up a complex authorization system and audit logging in order to know exactly who has the right to do what and who does what at which time, of course. So this is basically how you deal with it. It's very complex, very heavy, and we all know that when you've worked in a bank, you know what I mean. Second aspect, fault tolerance. Well, you start by setting up redundance to replicate your servers somehow, so that even if one falls apart, then you can switch to the good system. But then you end up having to deal with how do you maintain a transactional context across those servers, and you have to set up complex middleware and maintain it, and all that had some complexity to the system. And the third aspect for censorship, well, you have to set up some access points, some APIs, and of course you need to secure them, again, adding some complexity to the problem.
Yeah, yes, but today we live pretty well with this kind of constraints. What's the alternative?
So basically, again, the motivation of the Bitcoin was really to turn the system upside down somehow and build an alternative that was decentralized, meaning that we need to solve those problems in a different way. So in a distributed and decentralized database, the first thing we start with is we distribute the data on the nodes of the system itself. We don't keep it in a central place, we distribute it across the nodes of the network. And not just the data, but also the control over that data, the governance itself. Thanks to those things, well, the fault tolerance is pretty much built in. Okay, you have a network in which even if a node fails, then the data can basically work around it, and everything is good, and it's built into the network. It comes for free. Second aspect, transparency. So to solve the censorship issue, if you want, well, everybody can audit everything that happens because everybody can see all the transactions. Now, of course, this comes at a cost, and to balance things out, you need anonymity as well. So in other words, you can see every transaction, you can see every change in the network, but you don't know who is hiding behind it. You just see numeric identifiers. And then, of course, the most difficult part in this, how do you agree? How do you agree on that, on such an important aspect as the order of transactions?
And how to find this agreement between all these nodes that are
Indeed.
distributed in the network?
Especially because all the data is distributed in all the nodes, and the problem is how do you agree? And that's really the key innovation in the blockchain. How do you reach consensus? So I won't go into too much detail now about the different implementation, but the general concept is the following. Basically, what you do is you build this ledger. It's the same thing as in the traditional banking system. You have this list of transactions, and they are ordered. But here they are ordered and packaged, bundled, if you want, into blocks. Okay? So they are bundled into blocks, and then those blocks are chained together. Starting to see where I'm going with this?
Blockchain.
Indeed. Cool. But they are chained cryptographically. Again, I won't go into too much detail about that, but the only thing you should know is that there are mathematicians who worked really hard to make sure that nobody can break this chain, nobody can change the order of the link in that chain. It's very, very safe. So those blocks are chained together, and then you have what we call a consensus algorithm that is used to determine one specific order for those transactions and especially for those blocks. Okay? And this runs on the nodes, and it's replicated on all the nodes in the network. So you have a specific algorithm that changes depending on the implementation again, but every node can verify that the order is cryptographically valid.
Okay, that's okay for the concept, but you mentioned implementation. Could you just mention some solutions that implement this concept?
So again, these are generic concepts, and there are several ways to implement them. I'm just going to go over a few criteria here, but there are many more criteria that we could mention. It's just to give you an example and illustrate the fact that each implementation comes with their own interpretation of those concepts. So we're going to talk about the algorithm to determine the consensus. Also, another important aspect is what we call the mining reward. In other words, how do you incentivize nodes to participate in the securization and the safety of the network, if you want, and the kind of impacts that it has on the way the whole system works. So let's start with the Bitcoin first. In the Bitcoin, the consensus algorithm is of kind what we call proof of work. Okay? So you might have seen that somewhere. Basically, the idea is that there are special nodes, and every node can be that kind of special node. We call a miner. And miners basically invest electricity and hardware in order to calculate some cryptographic puzzle to build the next block in the chain. And they compete to do that. And of course, when they compete in that, that's how they spend a lot of energy and electricity, and they have to invest in hardware to do that. As I said, in an open blockchain like that, you need to incentivize the miners somehow to participate in this security mechanism, in this consensus algorithm. And the way it's done in Bitcoin is using this cryptocurrency, the Bitcoin, as a way to reward miners. So every time a miner adds a new block to the chain, he's awarded with right now it's 12.5 Bitcoins, and this amount is actually halved every 4 years. That's one of the rules of the protocol. That's the way it's built, and there are different reasons for that, but that's one of the reasons why the total amount of Bitcoins is capped at the end. And also there are transaction fees, so every time you want to make a transaction on the network, you have to incentivize, again, the miners to include your transaction in a block, and the way you do that is by paying a small transaction fee. And the miner that finds the block gets to go with the transaction fees as well. Because of all the way this is done, and to keep a certain level of security, a new block in the Bitcoin blockchain is produced every 10 minutes or so. So that's just one implementation, Bitcoin. Now, about 2-3 years ago, I think, a guy by the name of Vitalik Buterin figured out that this system was nice, but it was really specialized on financial transactions and just for managing a cryptocurrency. You could do some fancy stuff with it, but to a certain point. And so he decided to build something new called Ethereum. It's just another implementation of the same concepts that we talked about earlier, but in a different way. The consensus algorithm is of type proof of work as well, at least for now. I'll mention it later. But here, the reward for the miners is not halved every 4 years. It remains constant. It's just 5 Ether. So, by the way, on Ethereum, you have another cryptocurrency that's called Ether instead of Bitcoin. And again, the miners get rewarded in Ether. You have another concept called uncles. I won't go into details in that, but it has some important implications about the security and the speed of the network. And you also have transaction fees, but in addition to that, you have a new concept called gas, because the main purpose of Ethereum was to be able to run more generic programs on top of the blockchain. And so that involves processing time and memory storage and so on. And you have to somehow pay for that. It's like when you pay AWS to host your application, here it's about the same thing. So you pay some amount of cryptocurrency to make your applications run.
Yes, but hold on. 10 seconds to generate a block
Yeah.
rather than 10 minutes, so it's less secure than Bitcoin, no?
It's not less secure, partly because of the uncle mechanism, and yeah, there are different reasons why it's. But indeed, the blocks are produced much faster, and it's just to illustrate the fact that just by choosing different ways and different rules, different ways to implement the concepts that we mentioned before, then you can get completely different results in terms of how the network works.
Okay.
And just to give you an illustration, right now Ethereum works like that, but there are some very important research projects going on, especially a new consensus algorithm called Casper. And the way it will work is, instead of working on the base of proof of work, it will be a proof of stake consensus algorithm. So basically, instead of investing in electricity and hardware in order to calculate what the next block is going to be, you bet. So you own a certain amount. You can prove that you own a certain amount of Ether. You put it on the table and you say, okay, I'm betting this amount that the next block is going to be this one. And then, of course, you have all the interest in the world to bet on the right block. And okay, this is very complex mathematics stuff. But basically, the main goal of that is to stop wasting energy, electricity, because, well, you know, the polar bears and the dolphins and all that.
Really?
So yeah, that's one of the reasons why they're doing it. Now, it's very controversial because it's not been proven yet, but it's very promising. And here, of course, the mining rewards are completely different. You don't have this static mining reward anymore. You have just the rewards of the bets, but you keep transaction fees and gas as well. And thanks to the way this system works, we estimate right now, it's not in production yet, so we don't know how it's going to work exactly. We estimate that the blocks are going to take about 4 seconds to produce.
So hold on. So I will create my own instance of the blockchain, generate cryptocurrency, so I will become rich.
Indeed, because all of that, of course, is implemented in code, and you can instantiate it as many times as you like. And by the way, some people have done that.
Yeah.
There are a lot of instances of whichever code base. I mean, the Bitcoin code base is particularly instantiated in a lot of places. Last time I looked at it, there were like more than 700 alternative coins, so alternate instances of one blockchain or another. So it's a very promising concept. But again, you have different instances of the same implementation. Basically, a blockchain is like a code base, okay? And it's the code base for the software that runs on each node in the network, including the mining algorithm, so the consensus algorithm. Now, you can decide to activate this algorithm or not, depending on whether you have the hardware and you want to increase your electricity bill to some extent. You can decide to participate in the consensus or not, but it's there. And all the nodes should have the same version of this code. Otherwise, the rules are not the same for everybody, and then you're not participating in the same mining process. So a blockchain instance is identified by a genesis block. So the very first block of the chain kind of defines the basis, the rules. It's pretty much like the DDL script in the SQL database, if you want. You also need a network identifier. This is used for all the nodes to participate in the same network.
To attach to the
exactly, to attach to the other nodes. And by the way, of course, if you create your own blockchain, your own instance of a blockchain, you create your own cryptocurrency that goes with it, and the cryptocurrency created on one network cannot be used on another, of course.
Okay.
And of course, you build this famous chain of blocks because of the software that you run on your nodes. What that also means is that if you run a different version of the software with a different set of rules, your essentially creating an alternate version of reality, an alternate chain, and that's what we call a forking chain.
Okay, let's back to the cryptocurrency. Why it's so important in the blockchain?
That's a very good question because the Bitcoin was created for the cryptocurrency, for the currency itself. But clearly, the objectives of Ethereum was just to be able to run any generic program on top of it. And so the question might be, okay, why did we need to associate this concept of a cryptocurrency to it again? It's very important to understand that in a public blockchain, the cryptocurrency plays a key role in everything. Because the main reason it exists is to incentivize nodes, especially miners, to participate in a consensus algorithm. Okay, if you have no way to incentivize them, then you end up, well, counting on their goodwill somehow. Now, this is the kind of things that the banks and some private chains are trying to do, but it works only in a specific context. And again, the goal of those networks is to work in a very large number of nodes where you cannot trust everybody, clearly. So you need to find a way to incentivize the nodes to participate in the consensus algorithm. And all that is based on game theory. It's very elegant. I really encourage you to read the white paper, by the way, to understand really what this is. Another advantage of that, another goal of this cryptocurrency, is to discourage forks and build trust. Why do I say that? Well, basically, as I said, you cannot use the cryptocurrency that's created in one network in another one. So you have all the interest in the world to keep your value in a place where there are a lot of people. If you start creating your own cryptocurrency where there are only 3 people mining and you're just in your own corner, then your cryptocurrency is basically worthless. It's like monkey money, monopoly stuff. So clearly the goal here is to build up some value and encourage people to stay in one central chain.
So this cryptocurrency are not monkey money. Can we compare cryptocurrency, Bitcoin or Ethereum, to euro and dollars?
Yeah, it can be. We'll see that later, but also it can be used here, and that's also one of the interests, is that if you build some services on top of the blockchain, then you can make people pay with it. It's basically like as if you had a credit card processing facility built into the network. So you might as well use that.
Okay.
So, and indeed, since you can buy cryptocurrency in euros or in dollars or whatever, then you can really pay for stuff. And on Ethereum, again, since the goal was to be able to run generic software programs on top of the blockchain, you have to somehow pay for the execution of those contracts, and this is also done in cryptocurrency. So, as we said, it started as a currency, and right now you can exchange a lot of those cryptocurrency against regular fiat currency like dollars and euros and so on. You can go to marketplaces like Kraken, there's Coinbase, there are plenty of Poloniex, Bitfinex and so on. You can sell your dollars and buy Bitcoin or Ether or some other coins in exchange, and you can sell them as well. And there's a marketplace, basically.
But it seems volatile, no?
It's very volatile. Yeah, we can see the value here. It's very volatile somehow, so it's still very risky to do that kind of investment.
Did you check it today with the election?
No effect. Yeah, of course, it has some big effect. I think the Bitcoin took $30 overnight. Anyway, and another important aspect is that it's not just a speculation currency. Somehow, especially for Bitcoin, since it's been around for quite some time, you can even buy stuff in Bitcoin. So you can buy pizza, for example. It's a very common example, but you can mostly buy online services like hosting VPN. Gandhi, for example, the French provider, they accept Bitcoin payments. So that's the kind of things that you can do. But again, we are not interested in that financial aspect, even though it started there. What is really interesting is the concept behind it and the architecture that comes with it. And because it opens way for many more applications than just the fintech applications, basically.
So could you please show us the other usage of the blockchain?
Indeed. So in order to understand what is it useful for, let's come back to trying to understand the basic logic. So if we come back to the logic of a payment transaction, it's almost as if you have a state S1, okay, with 2 accounts, and each account has a given balance. in bitcoins, for example. Okay? And then you want to transfer an amount, X, from account A to account B. So what you do is you run a transaction with a very simple piece of code that checks if the balance of A is greater than X, and if it is, then you transfer the amount, you decrease A of X, and you increase B of X, and you end up with a new state. Okay, so it's basically going from one state to another.
Yes, but you say that a block can be generated in several minutes. So how do you avoid the double spending problem?
That's indeed a big problem, because this kind of transactions, you can create them on each node in the network. And then we need to find some agreement and make sure that if I spend a certain amount of bitcoins, for example, in a transaction, I cannot spend the exact same amount on another transaction later and have both these transactions in the network. That's what we call the double spending problem. And the way this is done is really with this blockchain system, okay, with cryptography and with the consensus algorithm. The goal is to really avoid and completely prevent the possibility of reusing the same Bitcoin twice. So that's a payment blockchain. Now, if we try to take a step back and make the concept a little more generic and consider a more generic transaction. Here, in state S1, each account is not associated with just one variable, but potentially many variables. Okay? And the transaction itself can be much more complicated than the simple test and variable modification that we saw earlier. It can be any combination of tests, variable modifications, and even loops to implement some complex business logic. And the goal is to reach another state where the variables have changed value. Now, compared to the case that we had before, of course, this has some important implications. Mostly that those variables take up some space, some memory space, okay? And also that the transaction itself is somehow more complex, and depending on the transaction, the code is going to be more or less complex, so it's going to take some processing power as well. So if we translate that in the new blockchain, you could say that each transaction has a different size, if you want, and takes up a different amount of memory and processing power. So that's really what transaction blockchain more looks like.
So it looks like a worldwide computer.
Indeed. What we saw here is that since the transactions become really generic, it's basically like a giant, universal, global state machine, if you want. So it's a world computer.
And do you have some use cases that could benefit from this generic transactions?
So, as we said, these are really generic transactions. So basically everywhere there is a registry of order transactions that nobody should be able to tamper with, that's the key element, there is an opportunity for a blockchain, really. So, for example, of course, the fintech industry is really interested in that, and not just for currencies, but for derivative products, for securities, for insurance. There are plenty of cases where this can be interesting.
Okay.
But you can think of plenty of other examples. For example, in an election.
Oh.
Just random example. You can make sure that when somebody registers on the registry of voters, he cannot do it twice. And when he places a vote in the ballot box, he cannot do it twice as well. So you need to keep track of everything that happens. So it has some very interesting applications in the democracy sector, I would say. We can also think of healthcare. So, for example, organ donors. You don't want people to be able to change their order on this list of organ patients. I would say patients needing an organ donation, and there are plenty of aspects here as well as medical records and so on. Another application is in everything related to innovation, like patents and so on. It's also the same thing. What you want is to be able to prove that at a given date, you registered you described an invention, and you are the owner of this invention. Mm-hmm. And all that can be guaranteed by the blockchain as well. Another example is in everything related to contracts and document notarization, especially. So contracts like marriage contracts, land ownership. Of course, you want to keep some order in that, and make sure that you cannot, marry two wives at the same time, or sell the same piece of land to two people. Anyway,
it's possible.
Plenty of applications there. of course, in governance, and when I say governance, I mean government, but also in organizations, in companies, in NGOs, whenever there is a record of decisions, when laws need to be written and so on, then the blockchain can be interesting as well. And you have applications in education as well, so you don't want people to be able to say that they have a diploma, they graduated from a university if they didn't, and this is the kind of things where the blockchain can be really interesting. And these are just a few examples, by the way, of potential applications, but everywhere you have this notion of a registry of transactions that needs to be ordered and should be kept absolutely safe, then there is a potential for a blockchain application.
And the blockchain can replace these use cases? I'm not convinced, sorry.
Yeah, indeed, you're right, because those applications, they already are implemented. You already have a patent office. You already have notaries who notarize documents. You already have governments and elections and so on. So what's really interesting to understand is what the blockchain brings to the table here. So basically, those transactions are business processes, okay? They make up business processes. And right now, those business processes are either run by people or by complex computer systems. And sometimes by a combination of the two, of course. And in order to run those transactions and secure them and keep them safe and keep the integrity of the data somehow, you need to set up some very complex systems, okay? And what the blockchain brings is to automate all of that and provide a lot of features that in normal computer applications you have to provide, you have to build custom, or to build middleware and plenty of tools and frameworks and so on. It replaces all that with features that are built into the network, and especially on the security side of things. So basically all of that in the blockchain world is implemented with the concept of a smart contract. Okay? So a smart contract is essentially a piece of code, but a piece of code that is secured. And that secured by meaning it is stored in the blockchain itself. So at the moment it's stored in the blockchain, it's given an address, and you can check at which date and by whom it was submitted. You know exactly when you run this code, you will know exactly which version of the code it is, and you can potentially link it with a source code. You can know what it does exactly. You can monitor it very easily. And whenever you interact with that smart contract, when you basically call services on a contract, they run those transactions. They run those operations. They run in transactions that are themselves secured and logged into this giant ledger, if you want. And those transactions, they run on a network, and then they are replicated in every node of the network, again, very securely, very safely, so that the same code runs on every node on a network, giving exactly the same result.
And is it similar to the notion of distributed application?
So indeed, that's basically what you are building here. Is you could say that smart contracts are microservices somehow. Okay, just to put a buzzword in there. Anyway.
Another one.
And so really the notion of a distributed application, or what we call also a DApp, is a set of smart contracts with a user interface, because those smart contracts are just pieces of code, but we need to have a way to interact with them, to call them somehow. And so the way we do that is, first of all, we deploy those smart contracts. So again, when you deploy them, they are given a specific address, pretty much like when you instantiate a variable, it has a memory address. Well, it's the same concept here. And those contracts, they can collaborate with one another. They can call one another. Again, like microservices. And also, those contracts, they expose APIs, okay, that you can call. And the way you call them usually is going through a UI. So you need some human user at some point to say, okay, I'm going to trigger this business process, basically, and then you let the contract do its work. Now, what's really important is that, as we said, when you call a smart contract, you essentially create a new transaction. So if there is a new transaction, there are transaction fees. So this kind of application needs to run in a specific context, in a new kind of browser, if you want. In the same way that the first World Wide Web applications needed Netscape and everything that came after it, we need a new kind of browser for that, because we need a special thing in the browser itself. It's called a wallet. And what this wallet contains is two things. First of all, it contains all the cryptographic keys that you need in order to authenticate and interact with the network. And also it contains a stock of some cryptocurrency that you can use in order to pay for the transactions that you trigger. And of course, this new browser is connected with the network in order to replicate the state across all the nodes.
And do you have some example of that?
So this concept, again, is implemented already. There are plenty of examples of apps. Of course, the most obvious one, the very first DApp ever, was Bitcoin. And you could say that the smart contract here is very simple. There's just one, and it does what we said, checks the balance, and does some transfer. It can do some more fancy things, but the essence is here. There are others, for example, Bitproof, they do document notarization, like we said. So you can register a document and say, okay, at this date I registered this document with this hash. So of course you don't store the document in the blockchain. We'll see why later. But yeah, basically you can authenticate documents. Another application, and that's kind of a new kind of application. So there are plenty of ways that the blockchain can solve existing problems better, but it can also create solutions for problems that couldn't be solved before. And this kind of thing, so the Augur is really a prediction market. So what a prediction market is you can make a prediction, okay? And any user can say, for example, I made a prediction that in 2020 there will be autonomous cars on Belgian roads. And I bet some amount on that. And it's easy to verify. We can check on the 1st of January of 2020. And if I win my bet, then I get the rewards. And everybody who bet the same thing or against it, well, you guess it. It's a betting system. What's really interesting in that is the transactions here are really, really small. So it's not really interesting in a traditional credit card processing world, I would say. But it becomes interesting on a blockchain where the transaction fees are so small. And also, it can be used by politicians and governments in place, to check what people bet on and get a sense of where the future is going somehow. So that's a really interesting application. It's still very early, but there are some interesting aspects to that. Another one is Elo3 Energy. So these guys, what they are doing is that they're experimenting with the concept of smart grids and microgrids for electricity distribution. So basically, how do you organize transactions between individuals in a neighborhood who each have their own windmill or their own solar panels on their roof, and how do they transact and interact with one another regarding the electricity they produce?
So it's the notion of prosumers.
Exactly. So consumers are also producers, indeed. And there are plenty of applications like that. There's provenance to trace goods, basically. There is, that's an example of a Belgian application, by the way, done by KBC. They did a crowdfunding platform. And yeah, I think that's pretty much it. By the way, this one, they were kind of limited because...
Yeah, legal issues, I mean.
They basically created like a secondary marketplace for startup shares, if you want. And those shares are not really recognized as an official and legal financial instrument. So technically it's working, it's perfect, but the government said no.
So do you mean that the blockchain can replace all the solutions?
Well, right now, all of that is very experimental. So it's still a little bit early, but still it's very promising.
Okay.
So indeed, we saw a few applications here. But the next question here comes, okay, what is it applicable to everything, like you said?
Is it a silver bullet? I don't know. Can I do everything with that?
Can it solve the Trump election problem for you?
Too late.
We have to make at least one joke about Trump
late.
in every presentation, otherwise. Just to remind people that they are not dreaming. Indeed, what we said is that the blockchain at the very basis is a set of design patterns. It's really a set of concepts. And as we saw for all those who read the Gang of Four book, if you try to shove every design pattern in a given application, then you're in big trouble. Everything, basically, when you have a hammer, everything looks like a nail. So the first rule of the blockchain is that you don't need a blockchain. That's the very first rule of engagement. It's the same thing for distributed computing and that kind of thing. Anyway, so that's already true because of the limitations that we're going to talk about, but also, of course, it's very early. We said it's still very experimental, so be careful with that.
Let's start with the notion of anonymity, because I'm really scared by the fact that the data is everywhere.
So indeed, it's part of the concept, at least for a public blockchain, is that all the data is distributed across the nodes in the network. And you have some specialized websites like Etherscan for Ethereum or blockchain.info for the Bitcoin, where you can actually see every transaction in a network, and you can even see the balance of each user account. You just can't see who it is there behind it, and that's the whole point. The way you enforce security is by not knowing who's hiding behind the identifiers. So it's kind of to balance out this fact that you need the data to check that it's consistent and that it's to be able to audit it somehow, but you don't know who's behind it.
And you also mentioned the notion of transaction fees. That means that I have to pay something?
That's another important aspect. So indeed, as we said, the miners need to be incentivized, motivated to participate in the consensus algorithm. And all that is done with cryptocurrencies. And there is some amount, again, on Bitcoin, it's 12.5 Bitcoins that are created, that are mined on every block. But at the end, the miners will only be rewarded with transaction fees. So it's very important that there are some transaction fees, and basically the amount of transaction fees that you put on a transaction is what decides when it's going to be integrated in the next block. So it's very important to consider the fact that you need to pay some amount with each transaction. Now, just to give you an idea, I took this transaction that's for an amount of 5 Bitcoin, which right now is about 3,000 euros, and the transaction fees is about 16 cents dollars.
And do I have to pay to read the data from the blockchain?
You have to pay to modify the data, to do the transfers themselves. But if you need, for example, when you check the balances on those websites, or when you just read the state of the Ethereum blockchain, then you don't need to pay. It's just when you modify the data itself.
And how many transactions are processed by the blockchain?
Yeah, that's a good question, because of course when you do all that in a distributed fashion, it has some very important impacts in terms of performance. So just to give you an idea, for example, the Visa network, if we take a point of comparison, right now they process an average of 2,000 transactions a second. And that's just the average. They can go much higher than that. There are some peaks. There already have been some peaks at above 40,000, I think. So technically, they can support a lot more. On the PayPal system, which is also centralized, by the way, they process an average of above 100 transactions a second. On Bitcoin, it's 7 transactions a second, maximum. It's not an average. It's the top capacity of the network. It's going to change a little bit in the coming months, thanks to some improvements in the algorithm normally, but that's pretty much where you are. And on Ethereum, it's a little bit more. It's about 20 right now. But again, the speed of the network is much slower than a traditional centralized system. So you have to take that into account when you decide on the relevance of the blockchain for your application.
Can I create synchronous application?
That's also another important aspect. So basically, when you create a transaction on the network, you need to wait for it to be confirmed, to be spread across the entire network, and that takes some more time on a distributed system than on a centralized system, of course. So on the Bitcoin blockchain, the general rule of thumb is that you have to wait at least 6 blocks to be sure that your transaction is integrated in the main chain and that it's not going to go away anytime soon, anytime at all. And so since each block is produced every 10 minutes, you basically have to wait for 1 hour in order to be sure that the transaction that you sent is actually validated. On the Ethereum blockchain is a little bit faster because the blocks are produced faster, every 17 seconds on average, and you need to wait for 12 blocks. So that's around 200 seconds. Still very slow, but we made a progress. And of course, when you do a call on a REST API on a centralized system to insert some data in a database, for example, well, it takes a few hundred milliseconds maximum. So that's also something that you have to integrate if you want to do real-time synchronous applications, or almost synchronous, then it's going to be a challenge.
Okay, so the blockchain is still created by humans, not an AI. So I can imagine that shit happens. If we have to upgrade the blockchain, how do you do?
That's also an important limitation, because we said one of the key aspects of the ledger is that it should be immutable. And if we want the ledger to be stable and immutable that way, it means that the software that decides how the blockchain is built should be stable as well. And indeed, on the blockchain, the evolution of the system itself is very slow. The reason for that is that basically, as I said, each node runs a version of the software. Okay, and if you change the rules by which blocks get added to the blockchain, then you run a potential risk of creating a fork in the chain itself. So there are mainly two kinds of those forks. There are soft forks. Okay, that is a special kind of modifying the rules by which you accept the blocks, and it's kind of complicated. But the consequence of those soft forks, is that they are, I would say, less dangerous because you mostly need the miners, so the nodes that participate in the consensus algorithm, to upgrade their software. If you have a majority of the miners, then you're good to go. But there is another version. Some modifications of the system can be done in soft fork, but some require actually a hard fork. It's another kind of change on the rules, and this time it requires everybody to switch. So for example, recently there was such a case on the Ethereum blockchain. There was a big problem that was noticed. There was a big bug somewhere. And in order to fix the problem, they had to do a hard fork. And because of that, now you have basically two versions of Ethereum. The same cryptocurrency has split into two different currencies. There's Ethereum main, I would say, ETH. And then you have Ethereum Classic, ETC, still being mined. And you have two versions of reality, basically. So that's a risk. That's very high. So because of that, we tend to avoid, slow down on the upgrades to the system, and that you have to be very careful before pushing something into production.
So we know that size matters. So what's the size of the database?
Indeed, because since every node on the network has all the data, basically has all the transactions stored, you need to be careful about that. Just to give you an example, on the Bitcoin blockchain in last June, the whole blockchain, when you really store all the transactions, is about 70 gigs. And it grows by 4 gigs a month. The Ethereum blockchain is a little younger. It's like 2 years old. And it already has 22 gigabytes. And it grows by about 2 gigs a month. And that is because, well, you have all the transactions. So that has two important impacts. First of all, you don't store a lot of data in the blockchain. You try to minimize the quantity of data that you put in every transaction. And the second aspect that is important is that it limits the kind of device where you can run a full node. So for example, right now, if you want to run a full node on your smartphone, well, you need the big ones with a lot of storage.
Okay, but if I have to create a brand new application, how to decide if the blockchain is suitable for me?
That's a good question, because right now, as we have seen, there are quite a few limitations, and there's a price to pay if you want to choose the blockchain as an architecture. And you need somehow a decision model. Now, I would say the easiest one is this one.
Oh, okay.
It's just one question.
It's an
but if it was the only decision model, then we wouldn't be here, basically.
Okay, done.
So of course there are others. We put the link here. And basically the questions are roughly the same. Okay, do you need a shared database? Do you need it to be secured? How many nodes do you have? How much do you trust them? There are a whole sorts of questions, and it's really an active field of research right now. So there are plenty of alternate versions of those blockchain decision models, if you want. That's the one from I think IBM for the Hyperledger blockchain. That's another one. I really like this one that works pretty much like a test in a Cosmo magazine. No. You just check the boxes, and the more boxes you have checked, the more likely you are to be in a case that's relevant for the blockchain.
Okay, so
I left the link here, and I really encourage you to have a look at this article.
I'm convinced. Yeah, you convinced me. Yeah, I'm ready to start my new application on blockchain, so I have to download IntelliJ for blockchain. That's correct? No?
Well, first of all, you need to gather some information. You need to, because for now we just explained the concepts, and I hope we indeed convinced you that it is worth having a look at. But the first thing is that you need to take some information, and really it's a very, very dynamic community, and you need to participate in the discussions, and there are a lot of them. So I just put some links here. A lot of discussions happen on Reddit for either Ethereum or Bitcoin or all the other versions. You have some special news sites as well, some magazines. There are, of course, versions of Stack Overflow for these kind of problems. You have some websites that have some very interesting news. There are even some Slack groups where the discussions are somewhat interesting somehow. And of course, you have the network monitors that I showed earlier to really monitor how the transactions work and understand the logic behind it. So those are the communities that are really interested.
No JetBrains, why?
So again, just a few before we dive into that. Again, I just put the slide here for you to have the links. Feel free to have a look. And we focused on Bitcoin and Ethereum because those are the two main, I would say, public blockchains right now, and they're really interesting. And there's some really interesting documentation there. So indeed, a few pieces of advice since we've started developing on the blockchains ourselves. Well, first of all, if you want to go to production quickly, if you have an idea that really needs to go live soon, have a look at the Bitcoin blockchain. As I said, it was designed originally for financial transactions, but you can do some more fancy stuff with it. And to some extent, when your smart contracts are really simple, and especially if they don't require loops, because there is no concept of a loop in the Bitcoin blockchain itself, well, you can use the Bitcoin blockchain. And it's much more mature than than the Ethereum blockchain. So it's a very important aspect to have a look at. Now, if you have something more complex, then you need to read some documentation and get into more generic blockchains. Now, be careful. The documentation goes out of date very fast because everything is moving like crazy. It's like the Far West. A new build tool appears pretty much every day. It's almost like JavaScript. No, not that bad. Anyway, you asked about IntelliJ for the blockchain. Well, is there a JetBrains person in the room somehow?
No.
Please have a look at it.
Oh.
I mean, we need some more. I mean, the development tools are really a nightmare. Right now, it's basically Sublime Text and your command line. Not kidding. And it creates a lot of problems regarding validation, bug detection, and so on. So we definitely need to improve the development tools around this. And as I said, forget about mobile apps for now. If your client really needs a mobile interface, then you're pretty much screwed for now. Things are moving. There are some ways to lighten the nodes somehow, but it's still very complex.
So even if it's an early technology, do you see any kind of opportunities for developers, blockchain developers?
There are a lot. I mean, of course, you've heard of it. Otherwise, you wouldn't be here, I guess. And you've seen all those announcements by banks working. Even MasterCard released a blockchain API last week. I mean, everybody is working on it, especially the banks right now, but it's not just them, just insisting on that. It's not just for fintech. And indeed, there are more and more projects that are launched. Sometimes, most of the time, they are proof of concepts, but there are some really interesting applications for the years to come. And most of those companies, I mean, they are looking for blockchain developers, whatever that means. So there's a big opportunity to train on those technologies and also to make yourself known if you know them. So for that, we have one more thing. So you may have noticed this Chain Skills logo at the bottom right corner of our presentations. Said and I, we have started working on this thing called Chain Skills. For now, the main goal is a network for people who want to learn about the blockchain and share the resources that they find. So if you go to chainskills.com, you have this blog where we share the resources that we find. Right now, we're working on 2 more initiatives. The first one is online training, especially on Ethereum development. So if you would like to train and discover how you develop real distributed applications on the Ethereum blockchain, feel free to register. And also, what we are creating is some kind of a network for blockchain developers to find projects and for companies to find blockchain developers. And I'll let you guess the technology that we are going to use to implement that network. Anyway, so if you're interested in any of those 2 initiatives, feel free to register on beta.chainskills.com, and we will keep you posted about the next steps. And that's it for us.
Thank you.
Thank you. And we didn't even hope that we would have 5 whole minutes for questions. So are there any questions?
There is a microphone there.
There's a microphone over there if you want. Otherwise, you can shout really loud. I will repeat. Yeah. Bingo! We found the first question I was expecting. So the question is, we mentioned the difference between private and public blockchain. So right now, as I said, the industry that's the most interested in the blockchain evolution is the banking sector. And the banking sector, as you might guess, they really like the distributed aspect of things because they see some potential for more efficiency and lower costs, especially compared to things like, I don't know, Western Union, SWIFT, and all those networks. They try to find some alternatives, but the decentralized aspect, no, they don't like that that much. So it's like they're buying Ferraris, but they're taking the engine away. So we're still trying to see how it's going to go, but so that's what the private blockchains are basically. So they remove the decentralized aspect of it, and instead of having this consensus algorithm that is based on mining and proof of work or proof of stake or whatever, they have a more permissioned consensus algorithm, meaning that you have special nodes that are very well identified and certified to have the authority to say this is going to be the next block in the chain. And this way, they kind of avoid all the problems that come with the public blockchains, if you want, but they also lose a lot of the advantages. So there are some alternatives like that. Have a look at Hyperledger, for example. They are looking a lot into that. So the private blockchain sector, there's basically Hyperledger is an interesting implementation of that. And then the banks are working on a consortium called R3. And especially on one technology called Corda. We don't know what it does yet. It's completely opaque. That's the problem. I mean, okay. Anyway, and they're really working on some private blockchains. I'm not a big fan of it, but okay. That's where the industry is going for now. Yeah. Sorry? How do you prove your identity? So, well, basically, you don't really need to. Because at least for most applications, you don't really need to. Especially, even for Bitcoin, for example, you could say, okay, but we have to identify who's behind it. No, we don't. The only thing we need to make sure is that you cannot spend twice the same amount and so on. Now, if we don't know who is behind a specific account, that's not a big deal. It's about ownership, but then that on some application is going to be interesting. For example, on the land ownership case that I mentioned before, indeed, in that case, you're going to need some way to link a blockchain address, so an identifier, with a real person. And for now, we don't have any solutions for that. That's one of the ways that some people think that the role of banks could evolve, just to maintain this link between the real person, the know your customer basically, and the identifier. Some other people think that nation states should play that role and build that kind of identification. But clearly, when you have a use case where you need that kind of identification, it's a problem. But it's interesting to think if you really need it, to wonder if you really need it. In some cases, you think it comes. Of course, it's obvious, but even in an industry like the banking industry, where you have all those know your customers rules and so on, well, you didn't really need it, and it works right now without being able to identify users. Yes? So indeed, so the remark is that we should have started the discussion by explaining the difference between the private and the public blockchain, and especially the fact that on a private blockchain, you don't necessarily need a cryptocurrency, you don't need a token value, and you can exchange without it. To be honest with you, we are very opinionated. We don't believe in the concept of private blockchains. For us, it's not even a blockchain anymore. It's an interesting concept, the fact that you distribute the data a little more. But for us, the real interesting aspect is the public blockchain and everything that it plays with game theory and so on. And we think that there are already a lot of interesting applications in that field. Again, I think most of the way we see it, there are basically two approaches. You have this new architecture, this new enabler of solutions, basically. You can either try to shove this solution into existing systems, or you can try to build a new kind of organization around that. So for us, the jury is still out, and we'll see where it goes, but indeed there's this difference.
Okay, thank you guys. Time is up. We will be around, so do not hesitate to.
Feel free to come to us. Yeah. Thanks a lot.
Thank you very much. Bye-bye.